Good afternoon and welcome back. So in this video, we're going to be returning to our project and creating our C++ classes. Now, this is the second time I've tried recording these actually. I'm trying to get a good kind of flow for the C++ tutorials. I'm more used to blueprints. Blueprints work really well for being able to visually explain something, and they're perfect for tutorials. C++ not so much. I actually spent 3 or 4 videos just creating the base player class. Now, I think we can get that done a lot faster. So the way that I'm going to approach this is we're going to create all of the classes so that they're ready to use. And I'm going to go through, I'm going to implement the functionalities and the variables into the classes. And I'm going to go back through this time and explain them where I think they are relevant and the explanations are needed. If this feels as though things are going a little bit too fast, then do try to stick with it because I will be explaining things at a point that I feel is required. What I did originally was tried to explain all of the concepts through C++ before we really needed them, and it just became a little bit overcomplicated. So I'm going to try and avoid that this time around. So like I mentioned, the way that I want to do this is that we've already got our classes made in blueprint form. So we're going to take this information that we already have, and that just means that when we start adding these things in C++, the references to them at least will be ready for us to call. So we only need 4 classes for this. We're not going to be doing the widgets in C++. It is completely possible, but it's also a huge pain, and most people don't tend to do this. So again, widgets are something which is so visual that it's a perfect opportunity to use that in the widget blueprints, and it just means that you can call them once in C++ if needed, and then everything else can be controlled in the widget class. So the only classes that we're interested in are going to be the endpoint, the game mode, the obstacle, and the player. Now to do this, we don't have any C++ in the project at the moment, so we want to go to the File tab and create a new C++ class. First one I'm going to start with will be our game mode, so we'll just scroll down to the game mode base. So we already have our class types available, and we just want to give this the naming convention. So most projects you'd have a naming convention, which would be like the first letter of the project name and then the type of blueprint it is. So I'm going to use the first 2. We've got Cube Runner, so I'm going to call this CR and then game mode. Now every other class that we make, we're going to have a CR player, a CR obstacle, and so on. The other option we have is that we can hit this public button and it will just place things in the correct files. So we're going to have 2 files created for every class that we create. We're going to have our C++ file and a header file. Hitting this button just means that they'll both be put into the correct file structure. So with that done, we'll hit create class and we'll wait for this to compile, and it can take a little while. Okay, so when that has compiled successfully, first of all, you should have the Visual Studio's code window open up. But before going over to that, I just wanted to show the new folder structure. So we now have our C++ classes folder. You'll see that we have our Cube Runner folder, and inside of this we have the public folder. We don't have a private folder, but we do have our game mode that we've just created. Now if we double click to open this, this is relevant because we've segregated this into public and private classes. So we'll see that we have in the left-hand tab over here, our crGameMode.cpp is in the private folder, so that's our C++ class, and these are kept private usually because other classes shouldn't be accessing this directly. So we can keep this private, and it's just slightly more secure that way. We then have our header class, which is under the public folder section. So this is because this is the header files where we'll be storing the variables, the declarations for the functions, and things like that. So other classes, when they reference things, they will be referencing the .h files, which are the header files, and the .cpp file of the same name will also be referencing the header file. So this is where the private and public separation will come in. So back over in the project though, what I want to do is finish off with making the rest of the classes. So we can now just right click on the C++ classes, and inside of this folder we can then create a new class, and we'll create our pawn. So we're going to call this the CR pawn. And what you might need to do just to correct the file structure there is just hit private and then go back to public if it wasn't automatically putting it in the public folder. And remember, this is of type pawn, so we're using the pawn class the same we did for the blueprint. And again, we'll create that, so that's ready for us in a moment. Okay, so again, inside of the public folder, we should now have our pawn, and then we've got 2 others. So we had our endpoint and our obstacle, both of which, if we highlight over these, were of type actor class. So the native parent class is actor. So if we just go back into the public folder, right click again, create a new class, and we need 2 actors. So we're going to create the first one, which will be our CR endpoint. And now, of course, if you right click in the correct folder straight away, you can see this is automatically defaulting to the public. So this is going to separate everything properly. Again, we'll just create the class here and wait for this to compile. Okay, with that one done, we just need the final class. So we're going to go to add C++ class again, go back down to the actor type, create next, and we'll call this one CR obstacle. So again, just double check this is going into the public folder. We've got the setup correct, and then we'll hit create, and this will be our final class that we need. Okay, so with the final class ready, move back over to Visual Studio Code. If you have the same issue as me, you've got a lot of the classes have been left open, we can just come up here to the Explorer and hit this multiple close all editors. This will just close these out for now. We can drop the debug console and the log just down a little bit. We'll need this for reference, but we don't need it to take up as much space. And what I'm going to focus on for the rest of this video is our pawn class. So if we open up the crpawn.h and the crpawn.cpp, just need to double click these to actually make them nest up here in the top of the tab. If you just click it, it just creates like a temporary reference to the window. And I just want to spend a bit of time going over the difference between the header and the C++ file. For anyone who's completely new to C++, this can be a little bit confusing. But quite simply, if we just look at the header file as a place to store the variables, so when we create or declare a variable or a function, that's going to go in the header file. And then whenever we need to reference those, that will be the C++ file. So if we think about blueprints, when we have our components and our variables tab to the left-hand side of the window, and we're creating everything there, and then we are using that in the event graph, essentially, and this is definitely not a technical way that this has been set up and has no relevance to each other, but just to visualize this, the left-hand side of the window where you're declaring all of the variables and the functions, that would be your header file, and then the event graph is going to be your C++ file. So that's really all we have here if we want to look at it that way. And as I said, that's very simplified and not in any way official. What I want to do though is I'm going to start creating some of our variables in the header file so that we can get at least one compilation done and start seeing some stuff happening. Okay, so the first thing we'll see is that we have a few different sections here, and the sections are identified by these words here: public, protected, and public again. So we actually have two public sections. So the first thing I like to do is drag everything from the bottom public section, and I'm just going to cut and paste this into the top public section and then get rid of the bottom one. We don't really need two of those. So the main difference we have here is public is going to be accessible by any other class and also any classes which are derived from this class. Protected is going to be accessible only by classes which are a child class of this one. So if we make a few different runner classes which maybe have different properties, maybe one will move faster than the default class, then anything which we put in the protected section would be accessible and usable by those classes, but it wouldn't be accessible by outside classes. And there's actually a third type, and this is private. And to add a private section, you just do the same setup again. So the word private followed by colon. And this basically means anything under this will not be accessible by any other class or even any class which is derived by this class. So if you make like I just mentioned, a slow pawn and a fast pawn, both of which are a child of CR pawn, then even they wouldn't have access to any variables or functions that you put in the private section. So for that reason, for flexibility, a lot of the variables that we create are actually going to be going into the protected section, just because this makes this quite extendable. If we did want to flesh this game out and have an option for the player to unlock different types of runner cubes or something, then it's going to be a lot easier to be able to inherit certain values. So we don't need to remake the class every single time we need a new cube. We can just inherit the things like the fact it moves, the fact it has input, but we can also then access these variables from the parent class. Okay, so just to finish this video off, I'm going to add a few of the variables into our protected section, and these are going to be the components that we already have in our blueprint. So if we just take a quick look back in the editor, if we navigate to our blueprint class, go to the player, the components that I'm talking about are the player itself, so the static mesh reference, the spring arm, and the camera component which is attached to the spring arm. So we need to create these in C++ and set these up first of all. And then we also have our variables over here, which we're going to want to expose to Blueprint again from C++ later, because it's going to be a lot easier to update these via blueprints than it will be via C++. Just like pretty much just an ease of life type of functionality. So with that in mind, the first thing we want to do is to create our static mesh component. So the way we do this is we want something called a uStatic mesh component. We need to provide this a pointer, so we're going to make this a pointer to the class of uStaticMesh, and we're just going to call this cube because obviously our character is represented by a cube. And what we have here, so the first thing you'll notice is the static mesh is what we want to create, and in front of this we've put a U, and this is just some Unreal specific C++ syntax. So anything with a U in front of it is basically an Unreal class, and this just has things like garbage collection automatically set up for it, so we don't need to worry about things like that. Now, on top of this, we also want to make sure that we can expose this in blueprints. And to do that, at the moment, this would only be available in C++ classes. So to expose this, we add something called a U property. So whenever a variable or a function, if you were declaring a function, you'd actually use something called a U function. But whenever these are above either a variable or a function, it gives us the freedom then to expose these to our blueprint class when we compile this. So what we want to do is we want our static mesh component to be visible anywhere. And inside of these properties and new functions that we have the option to declare some specifiers to just give the blueprint a bit of information of how it should interpret these. So the first thing we want to declare here is visible anywhere. And we can see now that this had some time to catch up on getting the autocomplete. So the one that we want, and this is coming from the extensions we had that I mentioned. And this is actually really cool. This is one of the things which Visual Assist and the standard Visual Studios packages don't include, are the autocompletes for the U properties, new functions and things. So what we can use here is our visible anywhere, and we want to make this only readable via the blueprint. So we want blueprint read only, and then we can define this a category as well by just typing category and then equals and then the name of the category. And I'm just going to call this setup, so anything which is a component I tend to put in a setup category, and that's pretty much everything done. So that is everything done in our header file. We now want to move over to the C++ file, because at the moment if we compile this, we haven't actually done anything. We've declared something, but we haven't told the class what to do with it. It doesn't really exist yet. So in C++, what we have here is all of our functions that we were looking at in the header file. So the tick, the set player input, and the begin play we can see just here. So we've got tick, set input, and begin play. So as I said, these are just functions. They have been declared in the header, and they are being used in the C++ file. So what we want to do is in the constructor, which I forgot to mention, is this ACR pawn, which is just the name of the class. Declared as a function essentially is what's called a constructor. This is where we'll be setting up the variables, what they are. So if we create a speed variable, you would set the speed to be 2000 or whatever the value is in the constructor. So inside of our constructor, we want to set up what the cube that we just created is. So to do this, we would say our cube equals create default subobject. And again, if we start typing this, if you've got the same plugins I have, you can get the autocomplete down here. So we want the create default subobject, not the create default object. So we'll get the create default subobject. We need to pass in the type of object it is, which is our use static mesh component. So again, we'll get the autocomplete here. And then outside of this, we just want to give it some text, which is just going to be the name of it, the visual representation, and I'm just going to call this cube. Okay, so we've now declared that cube is an object that we've just created, so it now actually exists, the type of object that it is, and we've just given it a name. And the final thing we want to do is we want to make sure that this is the very base component of our blueprint class. So we will make this the root component. So if we type root component, we'll get the autocomplete again here. This is an Unreal specific thing. It already exists. Basically, it does this by default in Blueprint, but we need to set this up manually in C++. And we just want to say that the root component is the cube, so equals cube. And that is it. So we now have a cube, which when we compile this, will be our default root component of this class. So we just need to press Ctrl and S, make sure that you have the X's at the top here. If we make any changes, we'll see this turns to a little circle, which means that that hasn't been saved. So make sure that you've made your saves and save the changes. Now, one thing you can do is if we press Ctrl, Shift and B, if you have all of the same things installed that I do, that I've gone through in the previous video, you can compile directly from Visual Studio Code by going down to the bottom, and you want to find the name of the project, editor, Win64, and the development build, which I've already got up here now because I've used it before. So this would compile it perfectly fine. Now, the only problem is that when you compile from the IDE, it's called a hot reload or a hot compile, and this tends to miss a few things. So especially things which are done in the constructor that we've just used over here, they don't get updated straight away. Now, the easiest way to get around this is to simply come back into the project. When you add C++ into the project, you'll get this compile button. And if you do the compile from the Unreal Editor instead of the IDE, then that bypasses that issue, and even the constructor information is updated. So this is why I mentioned in the previous video, although we can compile from the IDE, I tend not to anyway, for these reasons, just to avoid that issue. If you do ever compile from the IDE and a variable gets reset or isn't updated, that's because you're setting it up in the constructor, and it's a fairly known bug. So I'd recommend just coming back into the editor regardless of what you're using and hitting compile here. You probably noticed that whilst I was talking, that was successful at the bottom. If we go to our CR pawn class, we can actually create a blueprint from this. So I'm just going to create a blueprint. I'm going to place this in our blueprints class, and I'll just call this the BP_CR pawn. So I'll create that blueprint class. And what I want to show is that we now have our cube inherited. That's all we have at the moment, but that has worked. And this is the variable that we've created in C++. We can see over here that the parent class is our CR pawn class, and if we click on that, that will bring us into our file that we've been using. So all of this is linked correctly. That first compile worked, and this is basically how we add properties, variables, and components in C++ and transfer that over to Blueprint. Now, the very final thing I want to show is obviously I know ahead of time which of these properties and specifiers that I want to use, and all of this is showing as we'd expect it to. So the first thing to bring to your attention is there are a lot of specifiers and a lot of different things in C++ that, as I mentioned previously, if I try detailing them as much as I'd like to, we're going to be looking at 5 or 6 videos per class before we get through them. So if anything that I touch on is of interest or doesn't make sense, then just do a quick Google search. For instance, at the moment we're talking about specifiers, so type uproperty specifiers, go to the first documentation, and as I said, there are a lot of specifiers. The ones that we've used are the visible anywhere and blueprint read only. So if we go back to this documentation, we can see what we get from these. So visible anywhere indicates that this property is visible in all property windows, but doesn't allow it to be edited, which is the important thing. So that sounds like what we're wanting to use. So this is where you would find the other options that you have to include here. So what I'm going to do very quickly is I'm just going to remove the visible anywhere, and I'm going to do a recompile. And this is just an example of if you weren't sure of what you were doing, if you're starting out and you don't know which ones to include, or if you need to include any at all. So let's say that we try this first of all without adding that specifier. We'll go back over to the project, we'll compile from here again to make sure that this has worked. And then when we get our compile complete, we're going to open up our CR pawn again. I'm going to navigate down to the cube component, and we can now see that on the right hand side there's actually no details exposed at all. So we can see from this that we've done something wrong. So this is where, when you're starting out, if you don't quite understand why something's happening or what thing to use, a really good way to learn this in the Unreal Engine is that everything is readily available for you to read through. So when you've seen, for instance, that you've got a class which already exists and it has components that you can see, and you want those same properties in the details panel. Let's take, for example, we know that the blueprint class of character has a working capsule component and a mesh component that instantly allows us to view all of this in the details panel. So what you would do is you can come in, create a new character class like I've just done. Inside of the blueprint class, go up to the parent class and just open this inside of Visual Studio's code. So we know that we're looking for the mesh component, and we want to get all of the properties that that mesh component has. We want all of those properties on our own mesh component. So if we do a Control F and find mesh, navigate down to where we find the skeletal mesh and the U property. So here we have the U skeletal mesh in the character component, and we can see that it has the U property already filled out. So I mean, what we could technically do is if you didn't want to read through this and you just wanted to get something working, you could copy this and you could paste this into your class and that would work. But what we can look at is that we can see that under here we've got a few things. We've got the category is the character, which doesn't really matter to us. Categories don't really change anything. It is purely a visual thing and it will just put it in certain sections. But what we can see is that we have a few options. So the first thing is that this is visible anywhere, which is what we had previously. So we could try and take this, put this in our class and our U property and see what happens. We've also got blueprint read only. So again, obviously this kind of gives away in the name that this means that we can only read the properties of this via blueprint. We can't do anything else. This is no writing access, which basically means that we can't in blueprint say that I want the skeletal mesh to now be a particle component, because obviously that wouldn't make too much sense. So we can take this, and as I said, anything that you can see in existing blueprint classes provided by Epic, you want to know how that was obtained and how you do something similar, just open the C++ class. Obviously this is quite a big class, but you can jump to the specific component you're interested in, and this is a really, really good way to learn coding in Unreal. But for now, I'm going to take this visible anywhere. I'm going to go back to our header, and I'm just going to reinsert this where it was previously. So that's why I've chosen these components, because we need the visible anywhere to make the details and all of the properties appear as we expect them. Same reason that we don't want the skeletal mesh to become something random. We're going to make this blueprint read only, so we can always get properties in blueprint to say the cube, how big is the cube, where's the cube located and things like that, but we cannot say that the static mesh cube has now become a sound file. So with those changes made, we're going to save this. We'll head back on over to the project one last time. We'll compile this again to get everything back to a working condition. And whilst this is happening, I'll get rid of the new blueprint I created just to demonstrate looking into the character class. And then if we open up the CR pawn one last time, go back to the cube, we now have the details panel with everything we'd expect to see. So we can start adding things and filling things out as needed here. Okay, so I'm going to leave this one here. This was the slightly lengthier video that I expected to do. I've covered most of the things that I think are really important to understand when you're doing these things. The rest of the things we're just going to start adding them, and I'll try and explain them as and when we come up to new concepts. So if you enjoy these or find them useful, then please do leave that like and share the video around. That really helps. To be kept up to date with the latest content coming from the channel, don't forget to hit the subscribe button. That's really going to help as well at the moment, being quite a new channel. I need to get to that 1,000 subscribers number just so that YouTube will kind of pay attention and maybe promote it, and not necessarily promote it, but at least mention it when people are looking for Unreal content. So that's really going to help get the visibility around. If you could do that, much appreciated. As ever though, thanks for watching, and I will see you all next time.